In the last video, we talked about the Pythagorean theorem, which led to the Pythagorean formula, and how to use that to get the missing side of any right triangle. If you didn't watch that video, make sure you go back and watch that first so that you can understand how to use the shortcut to the Pythagorean theorem. Now, the shortcut is how Pythagoras came up with his theorem. So he came up with these numbers called primitive Pythagorean triples. And these are them, and your teacher may have talked to you about them in class, but it is helpful to maybe memorize these four sets of numbers. These are the most common ones. Other ones do exist, but we don't really talk about them as often. And so Pythagoras realized that if he took this triangle that had sides 3, 4, 5, for example, and he squared the 3 and the 4 and the 5, and he added them together, that 3 squared plus 4 squared would be 25. And that would also equal 5 squared, which is 25. And so it worked every single time. He then realized that he could scale these triples. So let's say, for example, if he took 3, 4, 5 and doubled all of the numbers, he scaled it by 2. And he made a 6, 8, 10 triangle. He realized that this theorem would still be true if he squared these numbers and added them together. 36 plus 64 is 100, which is 10 squared. He did the same thing if he tripled the numbers. So we can actually go ahead, let's just take this and we can triple these numbers. 15 squared plus 36 squared should equal 39 squared. And when I put this in the calculator, 39 squared is 1521. 15 squared we know is 225. And 36 squared is 1296. These two added together are 1521. And so 1521 makes sense in this theorem. So what he did is he came up with these triples, and you can actually use these as shortcuts. If you memorize these four sets of numbers, you can use them as a shortcut. So for example, in number 9, I'm looking first at the hypotenuse. That's what I think is the easiest way to do this. From the sets of numbers that Pythagoras came up with, I'm looking at just the hypotenuse. Which hypotenuse is going to be a factor of 45? And the only answer is 3, 4, 5. So that means that this triangle had to come from a 3, 4, 5 triangle. So the next thing you ask yourself is, how did I get from 5 to 45? And the answer is that I had to do 5 times 9. So that means the scale factor is going to be 9. And in math, we call the scale factor k. That is the symbol or the variable for scale factor. So you know the scale factor is 9. 27 divided by 9 is going to be 3. So that means that from the 3, 4, 5 triple, you've already used the 3 and the 5. That means that this height would have to be 4 times the scale factor to get 36. And it's going to take practice and memorization of using these triples over and over again. In number 10, I'm looking again at the hypotenuse. That's what I personally find is the easiest way to figure out where it came from. The hypotenuse that goes into 35 is again the number 5. So that means this came from a 3, 4, 5 triple. How many times does 5 go into 35? It would have to be 5 times 7. So now I know my scale factor is 7. 28 divided by 7 is 4. And so I know that this is my 4 side times 7. This is my 5 side times 7. So this base has to be 3, and then times 7 for the scale factor gives me 21. For number 11, 5 is not going to be our answer because 5 doesn't go into 39. The hypotenuse that goes into 39 is 13, and it goes in 3 times. So my primitive Pythagorean triple is 5, 12, 13 with a scale factor of 3. 15 divided by 3 is 5. And so I've already used 5 and 13, which means now I need to use 12. 12 times 3 is 36. If you don't have the hypotenuse, you can still do these shortcuts. It just might take a little bit more brain power. So I'm looking right now at these two numbers, 25 and 60. And I have to use number sense here because one of these numbers at least has to be a multiple of 5. So if I look at my answer choices, my only two options I can possibly use are 5, 12, 13 or 8, 15, 17. So I'm going to use some number sense here, and I'm going to say, okay, 5, if this was my base of 5, how do I get from 5 to 25? I multiply by 5. If my scale factor is 5, and I've already used the 5, could this be the side that would be 12 times 5? And the answer is yes. So that means my primitive Pythagorean triple was a 5, 12, 13 with a scale factor of 5. This is my 5 side, my 12 side, and the missing hypotenuse would come from the 13 side. But I have to scale it by 5, and so the hypotenuse is 65. In the next video, we're going to talk about how to determine if something truly makes a right triangle. That's all for this video. As always, if you found this video helpful, make sure you hit like and subscribe. You can find this resource along with many others on my Teachers Pay Teachers, which is Math with B.